Given question, engine operating on ideal Otto cycle has a compression ratio 12:2. The pressure and temperature at the commencement of compression are 1 into 10 raised to 5 Newton per meter square and 27 degrees Celsius. Heat added during the constant volume combustion process is 1169 kJ per kilogram. Determine the peak pressure and the temperature. Work output per kilogram of air. Assume Cp is equal to 1.004 kilojoule per kilogram Kelvin and Cv is equal to 0.717 kilojoule per kilogram Kelvin. Let us understand given data with the help of pressure volume diagram of the Otto cycle. Compression ratio is given, it is 12:1. If we observe pressure volume diagram, then this process 0 to 1 is for the suction and then 1 to 2 is the isentropic compression process where the air is getting compressed in the piston cylinder arrangement with entropy constant. Then 2 to 3 is the heat addition process. For this heat addition, volume will remain constant. Now, if we observe V2 is equal to V3. Then process 3 to 4 is the isentropic expansion process. So, during this process, entropy remains constant and process 4 to 1 is the heat rejection process. For this heat rejection process, volume will remain constant. So, V4 is equal to V1. And again from 1 to 0 it is for the exhaust process. Now compression ratio is given. Now if we observe V1 is more than this V2. So value of V1 is more than V2. So ratio of V1 by V2 is known as compression ratio and its a notation is R. So we will show here its a notation. R is equal to 12:1 and we will say that this is the ratio of V1 by V2. Now it is given that at the commencement of compression, that is at the beginning of compression, pressure is 1 into 10 raised to 5 Newton per meter square. If we observe 1 to 2 is the compression process. So at the beginning point 1 is there. So pressure is known as P1. So this is the value of P1 we have to take. Then temperature is given 27 degrees Celsius. So at the beginning temperature is T1. So it is 27 degrees Celsius. For the calculation we have to consider this temperature in Kelvin. So we will convert this degree Celsius into Kelvin. So 27 plus 273 that is equal to 300 Kelvin. Heat added. Now we know that process 2 to 3 is the heat addition process and its a notation is QS and it is given 1169 kilojoule per kilogram. So I will show here the heat added, that is QS. Then the value of specific heat at constant pressure and constant volume is given. So this Cp and Cv values are given. So we know that this ratio of specific heats Cp by Cv is known as gamma. So how to calculate gamma? So gamma is equal to Cp divided by Cv. So we have to take its a ratio. Then the gas constant R, it is also getting calculated. R is equal to Cp minus Cv. So this is the relation in between these parameters. Now what we have to calculate? We have to calculate peak pressure. If we observe this diagram, then here is the peak pressure. So here is point 3 is having high pressure. So we have to calculate pressure P3. So here we have to calculate pressure P3 and we have to also calculate temperature T2, T3 and T4 because T1 is mentioned in the question. We have to calculate work output per kilogram of air. So with the help of this diagram we can also calculate the work output. Now we will first consider the process 1 to 2. So which is the isentropic compression process. So if we observe the compression ratio, that is values of V1 and V2 are known, but that is the ratio of V1 by V2 is known, and pressure P1 is also known. So how to calculate this P2? So we have relation in between pressure and volume. P1 V1 raised to gamma is equal to P2 V2 raised to gamma, where gamma is equal to Cp by Cv. So when we calculate, we will get 1.4. So P2 by P1 is equal to, so if I transfer this P1 to this side and V2 raised to gamma to this side, then we will get V1 by V2 raised to gamma. So V1 by V2 is R raised to gamma is equal to 12 by 2 raised to 1.4. So P1, if I transfer to the right hand side, then P1 is 1 into 10 raised to 5. So P2 is equal to 12.28 into 10 raised to 5. Now we have to consider the unit. So P1 is given in Newton per meter square. So this P2 is also in Newton per meter square. So we have to consider the pressure, that is the unit of pressure P1 mentioned, and then we have to show this. Now we will calculate the temperature T2. So again we have relation in between temperature and volume. So T2 by T1 is equal to V1 by V2 raised to gamma minus 1. So V1 by V2 is compression ratio. So we will take this and we will get the answer 2.04. So how to calculate T2? We will transfer T1 to the right hand side. So remember, for the calculation purpose, temperature always in Kelvin. So I will multiply with 300 Kelvin. So we will get the answer 614.3 Kelvin, and we will convert it into degree Celsius. So we have to subtract 273. So it is 341.3 degree Celsius. Now we will move to the process 2 to 3. So 2 to 3 is the process where heat addition is taking place at constant volume. So M is unit mass flow rate. So in question it is mentioned that there is unit mass flow rate of the air. So heat supplied or heat added is mentioned in the question, that is Qs is equal to Q2 to 3 is equal to mCv T3 minus T2, where Cv is the specific heat at constant volume. So here volume remains constant, so we have to consider Cv. Now what is the value of T3 and T2? So T3 value is unknown and T2 is we have calculated 614.3 Kelvin. So we will put here. So we will put all the values. So here Cv is 0.717, mass is equal to 1 because unit mass flow rate is given, and when we calculate T3, then it is 2244 Kelvin, and that is equal to 1971.7 degree Celsius. Now from this T3 we can calculate the peak pressure, because peak pressure we have to calculate, that is P3. So what is the relation in between pressure and temperature? So P3 by P2 is equal to T3 by T2. So we will put all the values. So T3 value is known, T2 value is known. So we have to take these values in Kelvin, and P2, that is we have calculated in Newton per meter square. So P3 is equal to, we will take the same unit as the P2, 39.4 into 10 raised to 5 Newton per meter square. Now we will move to the next process 3 to 4. So we have to calculate the temperature T4. So again there is the relation in between this temperature and volume. So T3 by T4 is equal to V4 by V3 raised to gamma minus 1. But from the diagram we know that V4 is equal to V1 and V3 is equal to V2. So we will put the value. So V1 by V2, and V1 by V2 is compression ratio. So we can say that it is equal to R raised to gamma minus 1. So when we put value, we will get 2.04. So how to calculate T4? So T4 is equal to T3 divided by 2.04. So we have to take this T3 in Kelvin only, and then T4 we will get 1100 Kelvin. Now we will calculate work output per kilogram of air. So it is the area of PV diagram. So how to calculate area of PV diagram? So area under 3 to 4 minus area under 2 to 1. Now I will make here one construction. I will connect this 4 to 1 line to the bottom line, and here also this 3 to 2 line I will extend, and this point of intersection is point C and this is the point D. So area under 3 to 4, that means area of 3 4 DC minus area under 2 to 1, that means area of 2 1 DC. So we have to calculate this. So how to calculate this? So area 3 4 DC is equal to P3 V3 minus P4 V4 divided by gamma minus 1, and area under 2 to 1 is P2 V2 minus P1 V1 divided by gamma minus 1. So here if we observe, why to take P3 V3 first? Because this pressure is higher, point 3 pressure is higher than the point 4, and why to take P2 V2 first? Because the point 2 pressure is higher than the 1. Now if we observe this, then we have to calculate work output per kilogram, that is mass is unit mass, so M is equal to 1, and this PV is equal to MRT. So M is equal to 1. How to calculate R? So we know that R is equal to Cp minus Cv. So it is 0.287 kilojoule per kilogram Kelvin. So we will use these two values. And this gamma minus 1 is 1.4 minus 1, that is 0.4. So this, if we put here MRT instead of PV, then this T is variable, this M and R will remain constant. So I will write here MR inside the bracket T3 minus T4, and here also I will take MR inside the bracket T2 minus T1. So we have to take this R divided by gamma minus 1 outside the bracket, because this gamma minus 1 is also the constant term. So inside the bracket T3 minus T4 bracket complete minus in the second bracket T2 minus T1. So we have to solve this term first and then this term, and then only we have to subtract these terms. So when we put the values, so remember always take this temperature in Kelvin. So when we put these temperatures in Kelvin, and we will take R value as 0.287 divided by 0.4, then we will get the final answer 595.3 kilojoule.